around? No. So that's why it's the answer. There's no ATP involved. Okay? Now, a couple other things to point out about this. The enzyme that does all of this, that put that phosphate on there, also was responsible for doing an oxidation. Since it's doing an oxidation, what kind of enzyme is it?
Dehydrogenase.
Dehydrogenase. It's not a kinase. Even though phosphate got put on something, it's not a kinase. You could envision, because I've done this in other years, you could envision a question, which of the following does not involve a kinase? And it could be that I could use the same reaction to ask that question. I want to write that down. Or not. Okay? Okay? If I ask a question and give you a bunch of reactions and say which one of these doesn't involve a kinase, that's a good choice for the right answer. Because there's no kinase involved. So obviously the answer is not E. Now, they'll explain why it's crying to you later. It's a crying, it wasn't happy. My eraser's better than theirs. My eraser's better than theirs. Okay, now,
This is where I started.
some of you wondered how are multiple choice tests? Can I ask you about how things get from one place to the other? Because it's hard for you to have to draw arrows on a multiple choice test, right? Question 2 is an example of how we can play this game. This is also, by the way, how they figured out how things happen in glycolysis. Is they'd start off with like glucose that was radioactively labeled in one place, feed it to some poor little volunteer animal or bacteria, and then later on kill it and isolate all the intermediates and see where the label was in the intermediate. Doesn't that sound like a lot of tedious fun? So, now remember, you're going to have a chart that has all the steps in glycolysis with you. Okay? And we're going to put the label on that carbon right there. Okay? We're going to put the carbon label on that carbon. Now what you want to do is start going through the steps and follow where the label goes. Okay? So, we're not going to go through the mechanism here, but ultimately we went to fruit. We turned this thing into fructose 1,6-biphosphate, right? Of course, the steps. So when we folded this thing into fructose, the label still stayed here. Everybody agree with me? Everybody agrees? Because all we're doing is we're playing around on this side, so the label's going to stay in the same place. You know, it's staying on carbon number 5 if you want to use the numbering system. Okay? Now, when we chop the molecule in half, okay, which by the way, 1, 2, 3, 4, it means we're cutting between carbons 3 and 4. Okay? So we're cutting between 3 and 4. So that means what we've ended up with. The phosphate also gives you a handle on where the thing is. So when I turn this into glyceraldehyde, which one of those 3 has the label? Remember, this part turned into the glyceraldehyde, right? We broke this oxygen and its pair of electrons flip up there and form the carbonyl. So where's the label? In the middle one, right? It's still on the carbon next to the one with the phosphate. Because we haven't done anything to the phosphates, right? So here's the one with the phosphate, so just follow where it is. It's the one next to it. That puts it right there. Okay? Now, we're going to go through a series of things, and we're going to turn this guy into the glycerate. Into the glycerate. The label, we haven't moved the phosphate, so it's still here. Now we're going to have a little fun. We use the mutase. We move the phosphate. Have we rearranged the carbon skeleton? So where's the label? Everybody agree it's the one in the middle? Y'all over here agree? They're the noisy half. Y'all are the quiet good kids. Okay, there's good people over there. Except for him. Yes, everybody's pointing to him. Okay. All right, so the label is still there, right? And when I turn that into the enol, to the phosphoenolpyruvate, where's the label? It's still the one in the middle, right? Which is carbon number 2. So the answer is B for Bud. Everybody see what I did? You see what I did, sir? What? Because we changed the numbering system. Yeah. It's still the same carbon, we just changed the numbering system. If you look at the textbooks, they did the same thing. Yeah, on the test, make sure you refer to the numbering system the way I've numbered the atoms. Make sure you look at the way I've numbered the atoms. Okay? Okay? Everybody got that? Everybody heard that, right? Make sure you check how the atoms are numbered. So it's this one. And the way I numbered this thing was 1, 2, 3. Just for the hell of it. What you might want to try is picking another carbon, labeling it, and following where the label goes. I strongly urge you to do this. Because something like this is going to show up on the test. I may end up with pyruvate. I may end up with the glycerate. I don't know which one I'm going to end up with yet. I haven't written anything yet. I'm going to go buy beer today. I'm going to do this while watching the Celtics win tonight. The Lakers win tonight, you have a really hard exam. I once upon a time, when I first started teaching up at Rutgers in New Jersey, I was writing a general chemistry exam, because that's what I was teaching there. And the Yankees were playing the Dodgers in the World Series. And they blew the lead. And as the game got worse, the exam got harder. And it ended up with an average of 35. It was the hardest exam anyone's ever written. It was the first exam I ever wrote. So, first exams are always the hardest. But passing was a 20. So, I do always put a good curve on these things, right? I think an A was a 65 on that exam. No, you're going to pray for this. Jackson's girlfriend deserts him, before the game is over. Okay, but anyway, but I do suggest that you practice some of these. Because you can guarantee at least one, there will be at least one on the test. Maybe 2. All right. The next question, no one should get wrong. Okay? The reason no one should get it wrong is if you have any sugar, aldose or ketose, okay? If the OH is on the right side, it is the D form. If the OH of the last chiral carbon is on the left-hand side. It's the L form. That's all you have to worry about. You don't have to care about whether it's an aldose or a ketose